Hi, y'all. My name is Brenda Crespo Perez, and I'll be reviewing a case study on data mining to improve veteran healthcare. The agenda is as shown. I will be going over what data mining is, the background, introduction, method, results, and discussion of the study I had picked. So as a refresher, data mining is basically the process of uncovering patterns and other valuable information from large data sets. Data mining helps organizations solve big or small problems and improves decision making through analyses. There are various techniques used by various analysts and data scientists, including association rules, neural networks, and decision trees, to name a few. So, starting off with the background, each year the Veterans Health Administration, or VHA, provides services to over 6 million veterans. Suicide among military personnel and veterans is a topic of international concern, and the VA has increasingly focused on suicide prevention efforts. It has been found that veterans are 1.5 times more likely to commit suicide than their civilian counterparts, especially due to multiple mental and physical stressors. Detecting individuals who are at increased risk of suicide is a major clinical challenge. There has been a lack of studies evaluating the predictive accuracy of currently available risk assessment tools, which is why there's been a push recently towards the use of novel techniques to obtain information from unstructured data to build more useful models of suicide risk. So knowing the problem that our veteran community is facing, I had found an analysis that was conducted by Poulin et al., which was published in 2014 and is titled Predicting the Risk of Suicide by Analyzing the Text of Clinical Notes. The abstract is as shown on the screen. Feel free to pause this video at this time to read through it. But as an introduction, the analyst created a linguistic-driven prediction model to estimate the risk of suicide amongst the veteran community. The overall goal was to develop a suicide risk classification tool using clinical notes taken from a national sample of U.S. Veterans Administration medical records. Specifically, this or a similar model could be applied to a patient EMR to aid clinicians in determining individual patients' suicide risk. Therefore, the analysts conducted a case control study to compare the clinical note text from a cohort of patients who committed suicide with the notes from two cohorts of patients who did not commit suicide. Clinical notes that were written by clinicians were used as the primary data via the VA EMR. The notes described hospitalizations, procedures, surgeries, and other medical services. In addition to the free text, the notes included semi-automatic script-generated tables, notes that discussed psychological state, depression, and alcoholism were present for all three cohorts. The dataset for each group contained the following records. Cohort 1 had 1,913 notes, which rounded off to 27 notes per patient. Cohort 2 had 4,243 notes, which rounded off to 61 notes per patient, and Cohort 3 had 5,388 notes, with 77 notes per patient. The analysts built models of the datasets using supervised training with genetic programming, which is specifically a type of supervised machine learning system. The system can learn to recognize patterns associated with a known outcome. The models were constructed by converting the free text records into words or phrases datasets. The derived models then identified the combinations of words that were associated with suicide. The data was analyzed using an algorithm to generate the predictive models. As a result, a classification model was developed that was used to predict categories for new examples. The analysts ran the algorithm several times to produce many different models. The multiple ensemble models approach provides more reliable results than any individual model. So to evaluate an ensemble of 100 models with 5-fold cross-validation, they trained a total of 500 models. The final step of the analysis was to extract the predictive terms for each cohort. This step involved extracting the predictive terms from the models and then assigning the terms to the cohort from which they originated. For single word models, the predictive accuracy was approximately 59%, and scores for individual candidate models range from about 46 to 65%. The models that use certain word phrases or word pairs had significantly better scores than single word models. The phrases negative assessment for PTSD and positive assessment for PTSD carry very different meanings. This phrase-based approach was more accurate than a single word approach. For pre-selected word pairs, the individual model scores range from 52 to 69% with an average of 64%. So in the final experiment, the combined cohorts had a peak performance of 67% and an average performance of 65%, which is great. The results for possible relationships of keywords and known domains of suicide risk factors are shown on the screen. The analysts were successful at determining useful text-based signals of suicidality. They obtained accuracies of greater than 60% for ensemble averages of 100 models, and individual model accuracies reached about 67 to 69%. Given the small size of the data set and the nature of the clinical notes, this performance level represents a significant achievement. For a classifier, these results represent a statistically significant signal. Meanwhile, analysts showed that methodological words pairs are more useful than single words for model construction on EMR data. So furthermore, the predictive feature words that distinguished each group were highly revealing, especially for the suicidal cohort. The best explanations for the suicide group's predictive terms to medical literature descriptions of patient behaviors and conditions that are frequently associated with suicide. The most common observation was agitation, which has appeared frequently in literature as a marker for suicide risk. And thank you for listening to my presentation.